We actually have my dearest colleague on the developer relations team at Parity, who's actually doing the production in the back, and something went wrong. And so we could hear him say, "Hey guys, you're not going through." And then I saw the chat, we weren't going through. But hey, this is, like you said, James, life in technology. um,
Yeah,
but
should
I'm
we start from
assuming
the top here, Sasha? Should we?
let yeah, let's start from the top. Um, I think all I was kind of chatting about was, when we met in August, and what was particularly interesting when we met in August, which sort of what prompted us doing the seminar, was that you were talking about sort of a new release that you guys were working on, focusing on the features of Subquery that can enable cross-chain indexing. And at that time, I
Yeah,
don't think there
exactly.
was any
Because
docs.
at that time, right, like we just had the second version of XCM release, and I was there for the Polkadot summit. You were there for the education course, and on everyone's minds right now, or at that time, was XCM V2. Actually, I just see a tweet this morning when I woke up that V3 of XCM has just been merged into master. So things are moving on already. What kind of coincidence of days? And that's because, yeah, everyone at the time was just trying to figure out how we deal with these XCM messages and how do we keep track of them all? How do we know, when I send one to another chain, how do I know how that was received and what actions took place in the other chain? And how do I kind of monitor that and analyze that from a macro perspective? So we've been doing a lot of work in the background since then, one of which is multi-chain indexing, which I'm going to show today. But it really shows how these ideas that kind of ferment and these discussions that take place in these in-person events and these in-person summits in particular really gestate over time into actual products and features.
Yeah. Yeah, it's certainly true about the fast-moving pace of all this stuff. And I mean, just looking back, right, we're already talking about XCMv3, and at the time it was sort of getting comfortable with XCMv2. Um, and yeah, maybe that's a good prompt to sort of talk a little bit about the work you've been doing at Subquery, the problems that you're solving, and really like who's your customer. And I don't mean like particularly sort of big customers, big projects. I mean like who are the types of people that would be making most use of
Mm.
Subquery?
Yeah, sure. So I've actually got a slide for this. So before we kind of talk about what Subquery does and who uses us, maybe the best thing is to start with the problem, right? So the main problem that Subquery kind of sets out to solve here, or help alleviate issues around, and this is querying decentralized data. Now, when you store data on a blockchain, blockchains are amazing things. Polkadot is a stunning piece of work used by thousands, hundreds of thousands of people, and has over 40 different parachains connected to it. It's really good at kind of communicating information, communicating state, and verifying that state. But the way that data is stored on a blockchain is it causes some issues when you're trying to read or access or analyze that information. Blockchains are glorified linked lists, essentially. And for those that don't know what a linked list are, it's like a book full of pages. Every time you want to read a new block, you kind of have to turn the book over and look at a new page. And so if I ask a question simply like, give me the last 10 transactions that you have made on the Polkadot blockchain, you can't just ask the chain that. You can kind of ask the chain what's the current value of my address, or what's the current state of this, but you can't ask it for like, give me the last 10 things that happened over time that relate to my address. It doesn't really work that way. Because literally the only way you could solve that problem by talking directly to a blockchain is by literally leafing through each page, looking for a transaction that interacts with your address, and then taking that off and putting that in your app. So when you're building a wallet, for example, or a scanner, talking directly to the blockchain doesn't really work. So in order to build these increasingly complex and intuitive applications, we developers, we need better tools. And we at Subquery, we try to build this tool to help them query their data faster. Now, there's another problem as well, which I'm going to talk about today, about multi-chain. we talk to a lot of customers inside and outside of Polkadot. So we at Subquery, our home is Polkadot. We started in Polkadot. But we believe in this multi-chain future, and all of our customers do. It's quite new, but it's similar enough that you can kind of talk to all these chains very easily, but each chain does things slightly different in a slightly different way sometimes. Some chains implement a different palette to do something, or they might make their own palette, or they might extend their standard palette. They all do things just in a slightly different way, and that makes the things a little bit tricky when you're trying to look across the entire parachain landscape. And that's something that we're trying to help today with this new feature that we're going to go through, multi-chain indexing. So to answer that original question that you asked, which is, what is a standard customer? Well, really, people ask us all the time. The answer is it's any customer that wants to build a beautiful user interface, a customer that wants to be able to use data in an effective way in the application or in the use case themselves. What this traditionally means in terms of our biggest kind of customer verticals, we do a lot of work with wallets, with scanners, and with other kind of dApp developers. So if you're building a game or like a tool online to analyze something, those are kind of our standard customers. They want to view data, they want to aggregate information, they want to be able to manage a large amount of information very efficiently and very effectively. Does that kind of answer your question in a roundabout way, Sasha?
Yeah. I would summarize it as, your target customers are developers who really need to power so like more indie devs, right, that aren't already like part of a team or anything, but maybe developers that really just want to power their dApp with an indexing solution. Then you have your traditional.
Yeah, there are some
Right.
major teams in Polkadot that use us. Some big wallets that many people use every day. But it's open source, so even single persons, indie developers working by themselves that want to like just look at something, or build something, hack something together in the background, that could be the next big dApp. They will use it as well.
Right. Yeah. So I will just kind of prompt maybe you kicking off your presentation by saying the following. Like, I'm really excited about this particular seminar because we there's a huge gap in knowledge when sort of I'm going out trying to get new developers building a parachain or understanding how to build a runtime or maybe using some sort of tooling for runtime focused engineering really. And there's really a big piece missing, which is this piece, right? Like how to actually power an application in a way that can scale users, and you could just be a builder that deploys some cool dApp, and then the next step would be I need a good indexing solution. So where do I look? And there's sort of a gap in our developer journey currently, I think, that we can really be addressing with more content, highlighting tools and platforms like Subquery. I also I want to just kind of say that, like, this is a really powerful tool, but Subquery is a little more than just a tool, right? Like, I think we talked a little bit in Cambridge, you're kind of hinting towards the future of how can we incentivize these data sets to be completely decentralized and not hosted by centralized parties. So the opportunity is also like understanding this entire space of innovation. So I think with that said,
doing a lot of work
yeah,
now.
Do you have any comments on that? I know that your slides will touch on this, but based on what I just said, any comments before
Let's get to that at the right time, yeah. But yeah, we'll cover those and we'll have a little chat at the end, I think, to kind of to go over all the things I might have missed. But I'm looking forward to it too, Sasha. So let's dive in.
Sweet. Cool. Well, I'll go on mute,
Awesome.
And if there's any comments from the audience, feel free to use the chat to just put your comments in there. And if there's any questions too, feel free to interrupt in the chat, and I may or may not interrupt in the moment or save the question for later, so that I'm not too annoying to James's flow. That being said, the floor is yours, James.
Awesome. Well, we talked about the problem Subquery that Subquery solves. So in short, just to summarize, Subquery is an open source project that allows developers to index, to transform, and to query any Substrate data from any Substrate chain, but also other chains out there. We support Cosmos, Avalanche, Algorand, Ethereum. and even a network called Flare to power their applications. So it's like a custom API for your dApp. And you made a good point, Sasha, an excellent point, which is the education here. It kind of talks about how to build these palettes and how to deploy them and how to do these runtime upgrades and changes. But yeah, understanding this landscape of how you build a working, polished, decentralized application, that's a little bit murky. All the documentation and literature out there right now is like very, very Ethereum focused. And we've kind of got a diagram here that I've done to kind of explain this. Building on Substrate looks like this. So you have like a presentation layer at the top there that you would then interact with. Whether it's a mobile app, it might be using something like React Native or a native mobile app. You might then also, if you're using a web, you might have React or Angular or Vue maybe. You'll then interact with the chain probably through an RPC interface provider. Soon you'll be able to use a light client once they're kind of all polished off. But you might use a light client or an RPC interface provider. If you do, you might talk to a virtual machine. You might write some contracts in EVM using Moonbeam or Akala or any other of the EVM chains on Polkadot. Or you might use WASM, for example. So you might deploy it on Asta or Gear and use their new WASM smart contract execution environment. That will then run on a parachain. You don't really do much on the relay chain in Polkadot. It's not really designed to do a lot. You're designed to build these applications and deploy them to a parachain usually. That parachain obviously connects to the relay chain and syncs that data up. And you might have sort of throw on some extra stuff on the side, like some oracles to get maybe some price feeds or some real world data into your smart contract or your application. And you might use some decentralized storage providers. And if we put kind of brand names on these, or the one thing that's missing from this is where does Subquery sit? And you can kind of see by this terrible PowerPoint where I haven't actually removed the lines. Data indexing sits on the side. And the main thing here is it's unidirectional. Not unidirectional, it's one directional. So when you build this application, you design an application, let's say we're building a wallet. Your presentation layer shows all your transactions. It allows you to then create a transaction. When you save or interact the chain in terms of saving or upserting information, you would do that through the RPC interface provider. You generally do that directly to the chain. You'd submit a transaction to the chain. You would interact with the contract to the chain. Data indexing is about reading data. It's read-only data. And it works to then index information off that chain in their instantaneous fashion and provide that back to your presentation layer in a more aggregated form. So that example I gave before, you can't ask an RPC interface provider to give you a list of transactions that relate to your account. So you can't really show this list of transactions from an RPC provider. You would use a data indexer to index information, the historic information, and you'd use that to populate your application. But you would save information directly to the chain to make sure that no one else can touch it. So this is kind of the stack of building on Substrate, building a decentralized application, and it's tried and trusted. It's been used by many of the applications that you might use on a daily basis. And if we want to put some brand names here, just to kind of give this some understanding, you've got React to the front ends, might use IPFS on Finality, WASM or EVM-based smart contract layer, whatever parachain you want on Polkadot, and of course Subquery as the indexer.
Yeah. And so if I may just add some color to your explanation. So we could think of it as not needing an indexer at all. However, the overhead of the latency and sort of the really poor UX that breeds or brings to not having that is also sort of the reasoning behind having an indexer.
Exactly right? Like you don't need an index. Indexes aren't necessarily needed, but people these days expect fast, snappy applications that load instantaneously. And talking to the chain and loading everything, like Polkadot.js is a good example of an application that talks directly to chain. It doesn't use an indexer. And there's some pages in Polkadot.js that you can go to load like the history of stuff, and it will just slowly load. It's like watching dial-up. And it makes thousands of RPC recalls in the background to just build this history of, I think it was like staking rewards over time. So if you want to build an application that purely talks to the chain, you can, but it would be a terrible user experience. And that's
Yeah.
what we kind of really focus on as a data indexer is how do we allow you as a decentralized developer to create how do we allow Web3 developers to create a Web2 application experience? Because if we want to kind of bring this to the masses, that's what we need to do. We need to build these experiences that look and feel kind of so similar day to day to the average apps that I use on my phone or use on my computer. They don't look weird. They don't feel weird. They don't feel like I'm connecting to a blockchain rather than a centralized
Yeah.
server somewhere.
Yeah. Blockchains are
That's
really
really
slow and ultimately, very primitive machines.
exactly right. And you can't avoid that. That's what we're kind of building these tooling to work around these. They're amazing in a way. Like they're hugely scalable and what they're doing, they're actually quite performant for what they're doing. But what they're doing is constantly verifying that something's happened and making sure that it's true and all that process takes some time, which makes the user experience slow. So anyway, this is the application DApp tech stack that you might use to build an application on Substrate. And we build applications like this in the same way. So I'll kind of go back and kind of show you how we built our own one using this exact same process. So what makes Subquery unique? Subquery is a leading multi-chain data indexer. We focus on four things. We focus on building the fastest, the most flexible, the most open, and the most universal. So fast is important because indexing the entire chain takes time, but also when you save something to the chain, it needs to be in the data set, the index data set as fast as possible. So we focus on that speed as well. So how latent the information, how much latency for the information to come through to our indexer. And we've done a lot of work recently actually on being able to index unfinalized blocks. So the finalization process takes like 3 or 4 blocks, which is why sometimes you do something on chain, you have to wait like 40 seconds for it to start appearing and stuff because it's to finalize. And we're doing work to actually make that even faster by just pre-indexing stuff optimistically. And then if it's not finalized, we kind of roll it back. It's flexible, of course. You can build whatever indexer, your own custom API, make an index whatever data you want. And you'll be able to see this today in our demo that you can really index anything on Substrate. It's open source. You can go online and see examples out there. You can extend those to work with your own application stack. And finally, it's universal. So it's engineered to work across any Substrate chain, many leading layer ones. I kind of plan to get it everywhere. Another thing to this universal is that the way that it works across all these chains is so similar, which makes it easy to kind of replicate what you've done across all these different chains. And that's something we're going to really touch on today. So yeah, I've done way too much talking already. What I'm going to do is going to jump into a demo, a really basic demo that goes from 0 to 1. And we're then going to come back and do some more crazy stuff after this. So a Subquery project in a nutshell. Today we're going to show it. And I've got a link in the slides here so you can come back later in the future and see the project. But today we're going to do this example that we talked about. We're going to index every single transaction that's ever occurred on Polkadot. Very simple one, very straightforward. And there's 3 main parts to the Subquery project. I'm going to kind of go through the code here. This is a Subquery project. I'm going to zoom in so people can see what I'm looking at. I'm going to show you there are 3 files that you have to edit when you're building a Subquery project. And when you create a Subquery project, we have a command line tool. It kind of creates all this boilerplate for you. So you'll get an empty project, and all you have to do is update these 3 files. The first one is the GraphQL schema file. Now, the way that Subquery works is it indexes data from the chain, and it saves it in a format that you design and exposes that as an API for your application. And the format that you design is defined in this GraphQL schema file. So GraphQL is a language, it's like a REST API language, but it also, these entities that I define, there's 2 in this case, is transfers and accounts. They also create the database tables that we save data into. So I've got 2 entities. I'm indexing every single transfer event on Polkadot, which is why I have a transfer entity. Each transfer is an ID, an amount, a block number, a to, and a from. Very simple. You can imagine a table in our database, transfers table with these columns, these 5 columns. and imagine these get typed out into TypeScript types. Now you notice that transfers, the to and the from, relate to an account, which is the second entity. This here is a to-to-many relationship, technically, a many-to-many relationship. Each transfer has an account, there's two accounts, a to and a from, and I'm also indexing every single account that has made a transfer on Polkadot at the same time. So when I look at the accounts, I also save the ID, I save the creation block, and I also index every sent and received transfer that that account has ever made. And those are kind of like derived fields. You can see the kind of foreign keys across. So I can run a command called yarn codegen to then generate those types for me. So that's the first file. This is the shape of the data that I'm going to try to index today. The second file I edit is the manifest. The manifest is the kind of the what and the where am I indexing from. It's a bit of the kind of the configuration of the project. It looks like this. It's in the YAML file. The top part's pretty boilerplate. It just kind of looks at the supported versions of Node and Query services. The main part is down here where it gets a network. Now the network is the where am I indexing from? In this case, I'm indexing from Polkadot. So you can see I've got a public Polkadot RPC endpoint in there. I've got the chain ID for Polkadot, just so we can make sure that the network that we're indexing from, we verify when we connect to that public endpoint that it's the right network. And the chain ID for Polkadot is always the genesis hash of the network. I am also indexing or using a dictionary. And so at Subquery, we do a lot of work on making Subquery as fast as possible. And one of those features that we build to enhance speed is a dictionary. And a dictionary is a pre-computed index of every single event and extrinsic on chain. It means that rather than the indexer having to kind of peek into each block and saying, is there an event that I'm interested in this block, or this an extrinsic that I'm interested in? I can ask the dictionary, can you give me the next 1,000 blocks that has an event that is relevant to me in that? It just speeds things up. And so when
just,
we kind of look, you go ahead.
Well, yeah. So the question I do have in my mind is, you're saying it's indexing everything in the archive node, I imagine. But how can we
No,
specify
it's not indexing everything. It's indexing only what you want, and so that's
right?
defined
So where
down here in the data.
Okay. Because what's interesting is to sort of know, for example, like when did a runtime upgrade happen within the last, 6 months in block time?
Yeah. So we support, data sources, this defines think of them as like trigger functions. So any trigger points, and you can define multiple ones in here. And here I've only got one. I've only got a single handler that is a event handler. There's three types of handlers. There's block handlers. So a block handler does something on each and every block. So in each and every block, I want to run a function and do something. And this is good when you want to, like, for example, if you want to index the timestamps of every block to know if the block time is steady, for example. Or you can index every 1,000 blocks if you want to do like a daily update of stuff. Then there's event handlers, which we have here, and I'll kind of talk about them later. And then extrinsic handlers or call handlers, and they index the outputs of particular calls. So for my event handler, it looks for every event on chain that matches this filter criteria, and that uses a balances module, a balances palette, and looks for the transfer method. So whenever you make a transfer in Polkadot, there is a balances palette that emits a transfer event method whenever it sends a transfer. And you can kind of see this if you go onto if I go to Subscan, for example, on Polkadot, and I look at the blockchain here, you can kind of see. Let me bring it up.
Yeah, or an example that's very common in the blockchain indexing field of study, so to speak, is NFT transfers. So, given the NFT module, when did a transfer happen, and who was it to and from?
Exactly right. So you see here the balances. This is an example here, 23 seconds ago, where 14 dot was transferred from this account to this account, and you can see it's created by the balances module. and it's under the transfer method. Okay. And you can also go a bit further. So you can look, for example, if you want to index every governance action on Polkadot, for example, you can look at council, and you can look at council voted events. So every time a councillor voted on a proposal, this event's emitted, and you can get this information off it. So this is kind of what you're indexing off. You're indexing ideally off these events and these extrinsic calls. Extrinsic calls are slightly different, but work very similarly. So, for example, remarks, which are an NFT, it doesn't work on Polkadot, but they actually use this, I forget what the module is. It's like
it's on the system palette.
System remark. Yeah, that's right, system remark. And you can index every time a system remark is made. There aren't, I don't think, any, because remarks are just a free text, and then like look at the first string in this remark text to get what actually happened. So it'd be something like RMRK and then a string of decipherable numbers and letters to show what happened to the NFT. But yeah, this is interesting. It's like you can see a lot of information. So whatever you want to index, whether it's whether it's governance events or council voting, or you look at if you want to see or keep track of all the XCM messages that go through the relay chain. You can, for example, or any XCM messages where assets were trapped, how much assets have been kind of trapped and wasted or failed in the last few weeks. You can get that information from here, from these different events. So firstly identifying what events you want to look for, that's the first thing you need to do. And that's what we've kind of done here by identifying balances and transfers. It's very simple. Now, in a complex project, you might have multiple of these. You might have multiple different trigger points. So for that governance example, you might have a voted trigger point. You might also have a councillor elected vote trigger point. You might have a going up to vote trigger point, because there's all these different events that you might use to piece together this. So you might have approved, disapproved to update the status of the motion itself, and the proposed to create the motion, votes voted to update votes. So you kind of combine all these different events to then build a picture up of the data that you want and index information.
Yeah. I know on the flip side, for runtime engineers out there, it's like using your events and naming them in this particular way is actually really helpful down the line. Yeah.
Very helpful, yeah.
Actually, James, sorry, go ahead. We had a question, but finish what you were saying.
I was just going to say, if you wanted to do this for any other chains, this is for Polkadot right now, but if you want to choose this for, let's say, Moonbeam or Akala, all you need to do is change the chain ID, the endpoint, and in many cases, the same, but palettes are the same.
Yeah.
So for taking this project and making it work for Akala, it's just changing these two lines, the endpoint and the chain ID.
Yeah, I mean, I only know Substrate stuff. Actually, I wonder how different it is with the other blockchains you've been working on. But just a note to say that that's kind of also power of Substrate, and chains built with Substrate. It's like it expects the same metadata surface area, right?
Yeah, exactly right. Although some,
I guess, how does it some chains with what?
Some chains have their own palettes, of course, which you're going to have to go and find out the information for those palettes and those chains.
Right. Yeah. So how does it compare drastically to other blockchains out there that are not built for Substrate?
Yeah. Substrate is quite nice in terms of it has blocks, events, and extrinsics are the main kind of three things you'd look to index. If you look at things like Ethereum's slightly different in terms of it uses topic filters, which is like an ethers idea. It's like topics are like a function call kind of hash where you define these functions in your project and in your kind of contract files and index those. You look at chains like Algorand. Algorand's very transaction based, so you're looking at transactions and like you're filtering on asset IDs or application IDs or senders and receivers. What else? Cosmos is different again. It uses, it does have event, but it also has other things around transactions that you can use. So
Right.
like each chain has their own different terminology as well that we have to kind of adapt to because developers in that chain are familiar with that terminology of how they call things on chain. But it's the same kind of like a Cosmos event handler or a Ethereum call handler. And the filter patterns are different for those different things, but the same underlying way that you design this, everything I've shown you apart from this last kind of 3 lines would be the same whether you're putting it on Polkadot or Cosmos or
That
Ethereum or Avalanche or wherever.
so yeah, so that's really neat because it shows like how you've built Subquery in a modular way that can be kind of extended to different chains. Um, and so I mean, I guess I'm not, huge. I haven't really used and played around with GraphQL so much, but is that sort of the pillar piece of this puzzle to make it so modular?
GraphQL makes it easy to query. It makes it so you don't have to define a REST API. And I'll show
Right.
you how GraphQL works at the end. Let me just run the last file and we'll run this project. And I'll show you how GraphQL works because it's quite neat how you can kind of do some pretty advanced queries through it. And so let's go to the last file. This is the third and final one, the mapping handler. The mapping handler, so every time, what will happen in this runs is it will scan the chain for any events that match these criteria. And when it finds that event, it will run a handler. And this handler is defined as handle transfer, which I have written here, handle transfer.
Mhm.
And this is on TypeScript. It's very easy. Handle transfer receives a substrate event. And a substrate event is just a small wrapped kind of substrate event that includes the block. It's got also typed event record and the event from it as well. So you have a lot of metadata that you can use from it. What I do is I pull off the information from the event. So the way that data is stored in events and Substrate, and you kind of see this in Subscan, if I go back to balances transfer, is it's stored in an array, actually. Information on events is stored, or the payload of an event is stored as an array.
Mhm.
And you can kind of see this, well, not quite here, but these 3 things are a array. The parameters are an array. And the first element in that array is always the account ID from, the account ID to, and then the balance or the amount. And you can see that here. So from is the first element, to is the second element, and the amount is the third. It's a kind of a weird quirk around how Substrate stores information, but literally
Mhm.
all data payloads for events is stored as an ordered array. So we pull that information out. We then, in my example here, what I'm going to do, because I've got two different entities, I'm going to then create or make sure that we have an account entity already existing for the from account. So I check that these exist. So I try get one from the data set from toString to lowercase. And if that doesn't exist, then I create a brand new one. And I set the creation block to the block that we're currently on for this event. So on the header, number to begin. I do the same thing for the to account, so I make sure it exists, and if not, I create it. And then I create a new transfer entity. So for a new transfer entity, the ID has to be unique, so we commonly use in Substrate the block header number and the event index. You can see this, like even Subscan use that for the IDs. There's no kind of hash for these transactions like in Ethereum. People will often use the block number and the index of that particular event on the block, which is what we're doing here as well for the ID, and that's unique. And then we're saving all the metadata about that transfer. So in this case, I'm the block numbers from ID to ID amount, and I'm saving that to the data store. Now, inside this mapping handler, you can actually really do anything you want. So I'm just doing a very simple example where I'm reading some data off, I'm checking it exists, I'm saving new data. I can also update existing data, I can delete data, but I can take that a step further. I can then also maybe make an API call to get the price of DOT at that point in time, CoinGecko or some other third party, and save that in my data set with this information. I could make a RPC call to data on chain, and we'll see this coming up next. So you
Mhm.
kind of can write anything you want within these mapping functions. I've also imported certain interfaces as well from Polkadot types. you're free to do whatever you want with these mapping functions. And you'd kind of write a few of these mapping functions to take all this information off chain and update your data set. And once you write these 3 files, the schema, the project manifest, and the mapping file, then you can run it. And running it's very easy. It runs using Docker. I have a command here called yarn dev to, you can see that it runs code, and it does docker compose pull, docker compose up. So this will pull everything locally. It will then run that, and it will start indexing that information. You can see here it's set up a Postgres database. So the way that it runs is it has 2 packages or 3 packages. It has an indexer, there's a Postgres database, and a query service. So the indexer talks directly to the chain, directly via the RPC endpoint that I defined all the way back here. It then processes that data as we defined with these handlers and these mapping functions. It saves information to the store, which is a Postgres database, and then also provides an optional query service. And you can see here, my font's a bit big, but it is enqueuing blocks, it is indexing these blocks, and it's working its way behind the scenes. It's indexing blocks because there's not many transactions, it's kind of skipping a lot. And that's what the dictionary does. It's the entirety of the Polkadot blockchain, which has 13.8 million blocks, which is why we work to make this as fast as possible. So I can then query this using GraphQL Post. I have a playground, make some queries, and let's write a new query here. And I'll call the first 5. I'm going to order by block height descending, and I'm going to ask for the nodes. This is GraphQL language. I'm going to get the ID, I'm going to get the from ID, I'm going to get the to ID, and I'm going to get the amount and the block number. And I'm going to query that, and you can see here, this is data being indexed real time. So I'm going to index up to the 58th, 84,000 block. And this information in JSON. So this is safe to make calls from an application. If you're building a wallet, you can make GraphQL API calls to the Subquery project, and you can ask for anything you want. So for example, if I want to order this by the amount descending, let's ask for the highest, what was the largest Polkadot dot transfer? It was that amount of dot on that block so far between these 2 accounts. Or I can say, give me all, instead let's look at accounts. Let's look for the count that has the most transfers. Send transfers count sending. And let's get the transfers, send transfers, and ask for the first 5. It's all for pagination. And do total count, but also ask for nodes and get me the ID and the to address, the to ID, and the amount. This is the account here that has made 916 dot transfers by this point in time that's indexed up to. And the largest one it made, or the most recent one it made, was on that block, on the 891,000 block, to that account for this amount. So if you're building a wallet, for example, your question would be, okay, get me, this account has just logged in, and I would go account, make a query called account ID is that, it's a string, and this will get me this information. So some brackets. This is how you'd build these real world queries to build an application. So this is a query that a wallet would use to show all the transfers made by this particular account, and they would paginate sent transfers. And this is exactly that use case that we said to do. The last, in this case 5, but say 10 or even 50, say 50 transfers from this account, or ordered how you want them. So this is GraphQL. This is why it's so good. You don't have to define this REST API. You don't have to do anything more than define these entities here. It gives you all that kind of the ability to create whatever you want in as complex way as you want. And you saw in the past we even did this we created a nested field in an object. We queried the we started by account and then we listed all sent transfers from an account, which is pretty cool. So yeah, that's GraphQL. And that's kind of
Super
what we've
neat.
just seen here is how easy it is to create a project, in such a short time. The indexes all transfers and how you can use the filters to speed up the indexing, dictionaries as well, and how you can mutate the data in your mapping functions. Super neat. But we're going to take this next step further. We're going to go a whole lot of more complexity, Sasha, very quickly, okay? So strap yourself in. We're talking about multi-chain indexing now, okay? So we got one here, the indexes transfers from Polkadot, which is cool, but everyone's got that. It's not that difficult, pretty straightforward. We're going to index data from multiple networks. So a common example that wallets have an issue with is wallets want to show a unified list. They want to show, I want to give them my substrate, my generic substrate address, and they want to be able to show me every single asset I have in all the parachains. And they want to show me an ordered list of every interaction I've ever done on every parachain. They want to show me an XCM. Let's say that, for example, they want to show that I sent some glimmer from Moonbeam all the way to HydroDX to trade, and then I traded it on HydroDX and I sent it back to Akala, for example. So this is a kind of the golden view of what application developers want to be able to do with the XCMv3. And it's something that this latest release might enable us to do. And it's something that we've been trying and working hard in the background to allow our customers to do. And so what we're going to do is we're going to index data from multiple networks, from Polkadot and Kusama as a short example. We're going to link up the accounts using a generic converted substrate address. And we're going to get the balance of each account after each transaction. So a whole lot level more complexity. Are you ready?
So ready. Strapped in.
All right, so first thing, let's start here. This is multi-network transfers project. Now, first thing to start with is very similar, okay? Look, this is the same kind of like manifest that we started with, okay? So we've got the same chain ID, we've got the same endpoint, we've got dictionary, and it's the same subscribing to a Polkadot event handler, okay? Looking for the balances, transfer. Nothing's changed basically here for Polkadot. The addition is we have another file, we have another manifest here for Kusama. And Kusama, the only difference in Kusama, as I said before, is just using a different chain ID, endpoint, and dictionary. It's using the same module, so nothing else has changed, okay? Just those 3 lines. So you can have multiple different manifest files that control how this project will connect to every different chain you support. So if you're running this at a larger scale, you might have 50 for every different parachain out there, okay? So first step, manifest files are very similar. Second step, our GraphQL schema. Now, it's kind of similar. We have an account entity and we have a transfer entity. So these two are kind of similar. Transfers, we're indexing every amount, the block number from and to. But we also are indexing, okay, let's say the event, the network name that this is on. So we said that we know that this transfer happened on Polkadot or on Kusama. And one thing we're going to do is we're also going to roll up the accounts here. So each account, when you have an account, let me just get some documentation up from the Excellence Wiki, generic. Right.
So
address.
James, this is pertinent now. It was a question that was asked before. I was going to come back to it, but since we're looking at the schema again, you've got a type that's ID of type ID. Can you explain what that type is?
So IDs always needed. It's always need to be a unique string-based ID. It's a GraphQL thing. GraphQL requires you to provide an ID, and it's a primary ID. It's just always required. The type ID is a string. The exclamation marks after the name here, this means that this is required. It's a mandatory field. But I can also add things like indexes on this. So for example, if I know that I'm going to search up on this field a lot, I can add an index like that. And that will also add a database index to that column. So it's kind of, it controls a few things, but it also controls how it maps to the database that results. And we have documentation. We have a very deep set of documentation, which I'll share the links to after, that kind of go into the schema file, what these things different mean. So these are the different scalar types that you're supported. Begins, floats, dates, JSONs even, if you want to store just a non-structured data set, and how you can define indexes to speed up the performance on the database and the read, for example, how you can define entity relationships, how you can define uniqueness. This is many-to-many, for example, which we've seen, one-to-many. So we have a lot of documentation on this.
Mm-hmm.
Yeah.
Yeah, I was very impressed with your docs.
Thanks.
And I
It's
don't
one of those
just say that.
jobs that we have to do in the background. Anyway, so we've got accounts have a generic substrate account. Now, a generic substrate account, if I go to the wiki documentation, accounts addresses are different on different chains. So for example, Polkadot always start with 1. Kusama start with C, D, F, G, I, and J. And then there's a generic substrate address that always starts with 5. And that's something, if you use like the extension, the Polkadot.js extension, you'll notice that your account sometimes they have like a 5. And then when you go into like Polkadot.js, you see that like your Polkadot one has a 1. And your Kusama address is a D, and then each different parachain then has their own kind of like representation of that same public key. So what we want to do is we want to keep track of this one. This is the generic substrate address, and it works for every substrate chain. And so I've rolled up another layer above the account, which is a generic substrate account. And that idea is that generic substrate address that starts with the number 5. And then I can have multiple. So this user, if they say, for example, this user interacts with both Polkadot and Kusama, I will also save their Polkadot address and their Kusama address under this account entity. So, and then I will save all the transfers for all of those different addresses. So we've just added an extra layer of kind of aggregation onto the GraphQL entities. You with me, Sasha?
Yeah. So just if I could recap, you're really customizing the schema such that when you're going to be querying with some information about a transfer, you really have more granular information about about the transfers you're looking for, and specifically the account. You want to have an entire column that's keeping track of the account, or the type of account it is, i.e. like what type of substrate account, or sorry, what type of address format, in the sense that, we know that substrate accounts start with 5, we know that Polkadot accounts with 1, etc.
Exactly.
Is that pretty much it?
We know that,
I guess. Yeah.
Go ahead.
Well, so the only piece is that couldn't you have just used the information that you're retrieving from a single account and not needed to create a separate sort of field within that account? Wouldn't you have already had that information?
Absolutely, I could have. I could have disregarded. So when we receive these events on chain, if we receive them in Polkadot, we'll receive them with the name and account that starts with 1. Okay, and I could have just disregarded. I could have just immediately converted that to this generic substrate address, so it starts with 5, and disregarded that. But I want to keep that information, so I know that for this generic substrate address, they're associated, or they're kind of, child isn't the right terminology here, accounts, but they're network specific accounts. This is a list of all of them.
Right, and I guess it's just much more handy, much more easy to use data set.
What's all the known aliases on the different networks? And it also means that it's really easy to ask the data set at the end of it, give me all the chains that this person's interacted with, because if we don't know their account address ID for a particular chain, it means that we haven't seen the information that indicates that they've interacted with that chain.
Yeah, totally.
The last entity I'm throwing in the spanner here is this account balance, okay? And we might come back to this actually, because account balance is a bit more tricky. So we talked about the manifest, we're talking about the mapping, the schema GraphQL file. Now we're going to talk about the mapping handler. Now it's, again, very similar. So the way this works is we have 2 different handlers. We have a handle Polkadot event and we have a handle Kusama event. These are the 2 handlers that were defined. Now in my mapping function, I've defined these here. So they both receive a handle Polkadot Kusama event, and all they do is they just call this other event handler, this unified one, and they provide just a network ID. Now I could probably get the network ID off the event. Actually, I probably just did that. I'm just a bit lazy, so I just kind of created 2 and then kind of sent them through to 1. But that's all it kind of does. And this handle, it works very similar. Okay, it's pretty much the exact same thing. It first extracts data off the payload, which we know is in an array from, to, and value are the fields. Nothing changed. And then what I then do is I then convert the the account address to that generic Substrate account. And the way you do that is you decode it using this library from Polkadot utils.
Mm-hmm.
You decode that address. So this from address might be like a number, like 1D4, whatever. I then decode that and I encode that to network ID or to SS58 format 42. And 42 is an encode code for the generic Substrate address. I had a little search around the docs yesterday to find out what that was. But what will come out from generic address is that generic Substrate address format, 5D whatever. Okay. I then ensure the accounts exist. So I've doing the same thing I did back here in my simpler version. I'm just doing it kind of in a promise to make it faster. So I'm just kind of combining this to ensure accounts, and this calls this function to then check if the account exists. And if it doesn't exist, then creates it. And it also ensures the generic Substrate address exists as well, which again, it retrieves the generic Substrate address, and if that doesn't exist, it creates that. So there's a few layers here, okay? But it's the same thing, right? It's just checking that we have these entities in place before we save a child key, because it's like we have these foreign key relationships defined here. So if you try to save a child key with a foreign key, a child entity that has a foreign key to an entity that doesn't yet exist, it will have an error. So we're just saving all these like parents before the foreign keys before we kind of save the child key accounts. Okay? So very similar. It ensures the accounts exist. And then finally, it then, of course, creates the transfer event. It creates the transfer, saves the block number, saves the from ID, saves the from generic Substrate account ID, the to ID, the generic Substrate account ID, the amount, the network. And then the final thing I'm going to do today is I'm going to update the balance. Okay. Now, this project indexes the balances of the account, of every account that we've seen, at every block that we see it at. So every time we see a transfer that relates to an address, we go off and we ask for the balance of that address. And this update balance does that function. It has an account, a block height, and it uses a on-chain RPC call. You might be familiar with these kind of styles of calls from documentation if you've ever done an RPC call. Uses API query system account, and that returns the free balance or the previous free balance at that block height. And we then create a new balance entity, which again, back here, the balance entity has the account, which the ID is made of the account ID and the block height. It saves the account as a foreign key, the balance, and the block number at that balance, and it will save the information. So when we run this, which I'll just do now, it will go off and it will, this is actually quite interesting. So I need to do yarn code gen. I just need to update to actually, I think code gen. If I'm just doing code gen, but a particular file to code gen from, because it's like having issues. It's like, hang on, there's no project manifest. I can't find the project manifest because they're not named as standard. They're kind of named custom. Yarn build, and then so it's building it now, and then I'm going to run it in Docker using our yarn start Docker command, and that runs, pulls the images down, it creates a Postgres database, it spins up, and this is actually interesting. So the Docker compose file, you can see it's defined here. It spins up both, so two indexes. It spins up two indexes. It spins up an index to index Polkadot, and it spins up an index to index Kusama in parallel. So they're independent indexes running my Docker container. And if I open up Docker, I can actually see Docker here. And you can see here it's indexing. So it's got a Postgres database, a GraphQL endpoint, single GraphQL endpoint, and two different indexes, one for Kusama and one for Polkadot. And if I look at the logs here, you can see it's indexing data, securing blocks, the background, it's working away. And I can then go to my playground that I was at before, and I can start making queries. So for example, this is the account entity exists. So I'm here asking for, I think it's just still starting things up. No, that's the old one. Let me just find the right. Yep, don't do that. So here I've queried all accounts. So the first 50 accounts ordered by the balances. So which accounts have the most balance at this point in time. And I can get the ID, the network, if I ask that information. So for example, this is the Polkadot one as the highest balance. It's got 20,000 dot. It is on Polkadot. The Polkadot ID is 15KUT. The generic substrate account ID is 5GP. And it's all kind of converted already. Now, I've got some better examples. I'm not going to do this live because this is a bit tricky. So we just saw multi-account indexing with maximal code reuse. I'm using the same code across, apart from that one function for each, I've got pretty much the same code. Running the project in Docker with all these different kind of containers all spun up in the same command, and that's all kind of boilerplated for you. More complex mapping functions, including one that does an on-chain query within the mapping function, and it optimizes the speed by kind of parallelizing everything, and how easy it could be to support, say, 50 different parachains using the same process. Then we can do some complex queries. So for example, this is the same query that we made before to give me the first, the top 50 transactions or top 5
James,
transactions.
let me interrupt you and say for someone who's doing their first presentation all year, you're killing it. That was a really great demo, end to end of how to set up the different files for doing the cross-chain indexing stuff. Yeah, super cool. If I were to recap, basically, like, we're talking about setting up your schema, setting up your manifest file, and then doing the mapping, right? Once you have all those three things done,
pretty much.
boom, you just run, and then you can be querying it using the GraphQL interface.
Exactly right. And so some of the more complex queries that we can do, like this here, we've done this before, which is just give me the top transactions by amount descending. And you can see here, most of them are on Kusama because Kusama is one that launched sooner, so it kind of starts up earlier. But we go take a step next. So this one, for example, I'm a wallet. I want to show a list of all the single transaction, or every transaction that this account has made on all these different networks. And so I've used a single account here, 5CL, which is that standard generic substrate address, 5CL. And you can see here, this lists out all the transactions to and from this address, and they're all ordered. But you can see there's both Kusama and Polkadot transactions all in there, all in kind of like a sequential list, okay? So this is a kind of complex query that these applications, these wallets want to be able to do, which is show that single list of chronological order of every interaction you've done across any parachain. That's the kind of the outcome that we're trying to go for here. And I go to even more difficult stuff here. So this one is asking me to get the addresses that have made the most, or that have the most child accounts. So the addresses that have interacted with the most chains. In this case, I've only got 2 because we're only indexing 2 chains. But for each chain, I then ask for the account in that chain and all the transfers that made. So this address 5CLIS has 1H1 account on Polkadot, and they've made a single transfer, or they've received a transfer and they've sent a transfer. And then they have an account CRL on Kusama, and they've also made 2 transfers on Kusama. So this is the power of GraphQL. We can build these quite complex nested queries to then kind of make this really cool picture. And as a source, actually, you don't have to write your own REST API. You don't have to define all these types and models and stuff. It's like very simple. GraphQL is quite amazing, and it's safe to do from a mobile phone, from the internet, really easy. So that's kind of, I think, most of the cool. One more. Go ahead.
This is just sort of off the top of my head thinking like how I would maybe implement it slightly differently, which is that so knowing that every substrate address shares the same public key, couldn't you just sort of parse that into the checker and essentially not need to sort of try to customize each and every for each and every network, right? You would just do a conversion that checks whether that address can convert to that and matches that public key. That could be
Yeah,
cool.
so
Where then,
if you don't encode the address,
mhm,
you would then, a decoding address provides a public key. And so you can write like two hex. There's like a two hex function which then converts that representation to like a hex string. And yes, you can
right,
absolutely use that. You can index the public key instead.
yeah,
I was doing that in the past actually. I changed that because I prefer the substrate address because it's kind of like more visible. I see it a bit more every day. But yes, absolutely right. You could convert it to public key to this.
yeah, that's really cool. And the other thing, as we were going through this example, sort of the question that came to mind is, if we're looking at accounts that are interacting between chains, well, shouldn't we also be looking at XEM? But I think, so by that I mean like the XEM palette, right, that will emit certain events and that you can actually decode well, every XEM message will contain information that might be relevant for something you're looking for, right? But I guess like you kind of answer that question to me by saying, well, imagine I'm a wallet. I want to just know what are the interactions this account did with different chains, and you wouldn't get that from the XEM module. You
No,
would
you
only be
wouldn't.
getting cross-chain.
You would get cross-chain. So you can kind of say, yes, they interacted with another chain because they sent a message to another chain. So you could kind of say they interacted with the chain, although you might technically say they didn't because they didn't actually do anything directly on that chain. But if you wanted to do that, then all you have to do is index the XCM module. So I'm looking at a
Yeah.
Kala subscan here. And if I look at, I think it's XMPQ. And then you can just say upward message sent or XCM message, XCMP message sent. And if you index these events, then you can know that a message was sent from Akala to another chain. You can decode what that chain was based on information. So
Right.
yes, it's the same, this underlying format. You just need to change the trigger points and the mapping hammers, the same underlying format, the same kind of process that we've done, you can use for anything like that.
Yeah, but furthermore, to my wrong way of thinking in the beginning, which is like you would then need to actually decode what that message contains to get the address information, because you would have
And
like,
that's why XMV3 is a lot better. It's a big step in the right direction for us because XMV2, the way that the data was encoded in XMV2 made it really hard to understand where that was going to and what, in particular, what was the event on the originating or destination chain that caused that message. So you know that a message happened and you know the message was received, but tracking down the actual extrinsic call that triggered that message and the extrinsic call in the other chain that potentially resulted from that message in the past was very difficult. You actually had to do like a trace mode to like trace these steps within the block to kind of understand that. And there's a reason why you don't see much XM visualizers that show that because it's just really, really hard to get that. There's only one website that does it really well, I think, and that's Polkadot, because they took the effort to actually like deconstruct every XM event
yeah,
on the trace level to understand how it worked, to then understand, to be able to piece together where it ended up. And XMV3 is adding a few new fields that should allow people to provide a bit of metadata to be able to easily understand that this originated from this extrinsic. And it was sent here and it then created this. And that in V3 is going to be a real big help for us
yeah,
indexers and for other application developers who will easily understand the flow of information across these different networks.
yeah, definitely. Yeah, so that was sort of, if I were in the audience, that would be my question. Like, we're talking about cross-chain events. Why aren't we looking at the XEM module? And the answer is that, well, we just discussed what the answer is. Pretty much,
We'll have a seminar maybe in a couple of months' time about how to do
that'll
it
change.
specifically next year, maybe.
Yeah, super cool.
And then the last thing is I want to show this query here. This shows the balances of a particular account. So this account, this is how their balances change over time. So every block that you can see on the right-hand side, their balance changed because of some transfer that happened. And this is what we've been indexing in real time. So you can see how the account, if you want to graph this, you could easily graph this with the x-axis of the block number and the y-axis of your balance. This is what developers need. So the question is, how do you run this, right? You can run this locally in Docker. I've got running locally right now already. You can see it's still going in the background. But we also provide a managed service. It runs very easily. You can run it in AWS, but people don't run infrastructure it's a pain in the ass to run infrastructure. So we provide a managed service where many people run their projects for Subquery. And so, for example, if we look at our Explorer, there's a public list of all of these that make them projects public. You can see projects from Subscan, from PNS, from Suramitsu for Fearless Wallet, Talisman, Fala, Polkadot, for example, Capex, a DeFi product in Nakala. There's a bunch of Nova wallet projects, for example, that Nova and Subwallet use to index transfers and staking information across different networks. So yes, you can go and deploy your project here, and you can then query that using this GraphQL API all the way in this playground here, which is pretty cool.
Yeah.
Another thing that we're doing right now is we are trying to decentralize this, and we talked about this a bit, Sasha, in person. So having the centralized service that your app runs on, it's a risk, right? Because the whole point of a decentralized app is it's unstoppable. It's a word that Polkadot likes to throw around a bit, unstoppable, and having a centralized service in the way is a potential stoppability to your unstoppable app. So we're working hard to decentralize it, and we're working on a network. And the way the network works, we kind of believe it's the future of this infrastructure piece of your tech stack, and it's the last piece of that tech stack that needs to be decentralized with light clients taking out RPC providers. Essentially how it will work is that you'll write your project just so like done today, and you'll publish that to the Subquery network. And anyone around the world can then take that project and can be incentivized to run that for you. And run that for you and provide that data back to you in a trustless and verifiable way. So you can verify that two indexes are indexing the exact same data, they're the same outcomes. You can verify that an indexer isn't providing you a false data. And they do all the hard work behind the scenes in a trustless way. You get data for your application. And what that ultimately means is that you can completely decentralize your application stack, and it should mean better performance, right? If you have more decentralized indexes running your project around the world, it means lower latency, it means more reliability, more redundancy, better performance for you. So we're working on that at the moment. We're doing a lot of work, actually. We're just finishing off some of the final features around payment methods of how you pay indexes. We're building kind of like a way to pay for unit cost requests, which is a bit tricky on Substrate. But you can see here, this is like a UI. So this is how I would publish or index a project. So I'm an indexer. I'm indexing a project called the staking threshold on Polkadot, which indexes the staking threshold for validators at every era. And it's not indexed right now, but I'll start indexing. I could look at, as a delegator here, could delegate tokens to all these different indexes out here. I can see what their stats are. And what you don't realize is that this application that you're looking at, this user-friendly application, we build it using the exact same tech stack that we talked about at the start of the call. So we built it using a React presentation layer. It's running on a EVM-based virtual machine on a parachain. It relies on decentralized storage. We use IPFS, and it's using Subquery itself to provide the data to make that UI much snappier, much faster, much more real time. And so the Subquery project that runs this application, you can actually see it here in GitHub. It's a lot more complicated because it indexes like all these interactions, all these different events that are emitted on chain. But that same project, that same example I gave you today, you can take it the next step further. Let me see if I can find it.
So I wouldn't mind just getting really clear on what we're talking about when we're saying we need to decentralize the service. So my understanding is, we've got a data set that the servers behind using Subquery services are hosting ultimately, and we want a way to decentralize that, i.e., like for not a single server to be running it or hosting it, but many. And the solution to that is to incentivize it, incentivize servers. Correct. And workers. So that kind of reminds me of Filecoin. I think it's pretty analogous, except that it's very specific to running Subquery data sets. Is that correct?
Yeah, that's kind of right. And in a way, like you can't really, so someone has to run the subquery project, right? Someone has to run a database, a Postgres database that holds that data, and someone has to provide that or expose that data through a GraphQL endpoint. It's hard to decentralize that single point there.
Hmm.
But what you can decentralize is you can kind of make multiple single points. And what we've done the work around is being able to verify that all these different individuals are in kind of complete agreement, verified to give the same data out. And we use Merkle mountain ranges to kind of verify that the data that they've indexed is consistent. So we know that
Hmm.
this index and this index is the exact same information. And independently, we expect them to come up with that same information using that subquery project, because subquery projects inherently are deterministic. By default, they're deterministic. If you run a subquery project and I run one Sasha, it will have the same outcome. The data on the
Hmm.
blockchain is deterministic, and the way
Hmm.
you map it is deterministic. We do a lot of work to make sure that if for some reason like there's an error that occurs, it doesn't index, it doesn't kind of skip it. It stops and it kind of like, hold on, let's make sure we're doing this right. And so a combination of that determinism and that verifiability means that you can be confident that two indexes simultaneously running that project and giving you that data in different parts of the world would
Hmm.
be consistent, would be trustworthy.
Hmm. Yeah, totally. So and then I can directly see the costs associated to that, hence why Subquery has sort of these different tiers. One is free for developers that have, I think, up to 1,000 queries in a given month. Is that it?
Yeah,
But then
so
you've got
when we
other tiers, right?
this is for our managed service right now. The network hasn't launched, but the managed service, we provide a free tier. You can deploy two projects yourself and you can try it out. But we also pay tiers. We have some big customers that really
Yeah.
don't want it to go down. They're using production applications. So we work
Hmm.
closely with them to make sure that they're hitting at least 3.5 nines of uptime. So 99.95% uptime, which is like 4 hours of downtime. It's like one bad night's sleep
Right.
a year. And we do things like provide them advanced statistics, dedicated databases, read-write replicas, redundant geographical locations. So they might have an index running in Europe and in Asia, and we do a lot of work closely with them to make sure it never goes down. But the main thing is this managed service. It's accessible. You can sign up today, and
Hmm.
you can deploy your test project to it instantaneously, and it will work, and it's
Hmm.
free in that way.
Yeah, no, that's really cool. And but then I'm thinking, do as a user of this managed service, should I be thinking about kind of pruning my data set after a certain amount of blocks? Because if I start an indexing service, I'm just taking the examples that we did today in the workshop and the demos.
Mhm.
Um, we're looking at different balance transfers of certain accounts, let's say. Well, that's going to I'm going to in my manifest file, I'm going to be specifying what as of what block do I want to be looking for a certain event, and
Mhm.
it'll presumably kind of start there and then kind of continuously run throughout the lifespan of the blockchain if I'm a paid customer. But maybe after a certain time, is there a reason for me to prune it? I mean, I'm thinking
Um,
about the costs associated with keeping such a large data set over time, and it might be then cheaper to sort of say, okay, well, after a certain amount of blocks, we kind of we cut the data
don't need
set. We know that
that information.
we don't need that, but if we do need it, then we can kind of resort to an archive node or some other service that would maybe
Yeah,
uh,
so
provide that for me.
subquery inherently pruning is a concept like for nodes, right? It's to save storage space, which makes sense in a blockchain because nodes are very expensive and they save everything that happened on the chain. So I don't know how many terabytes a Polkadot archive node is right now, but it's large. But that's because it saves everything. Subquery is designed not to save everything, but a subset, just the information that you're interested in. We find the data sets are a lot smaller, and even some of the big production data sets on Polkadot the index like every transfer and stuff. We're talking about like, maybe like 40 gigs of data. Data is cheap in a Web 2 world because this is saved in a Postgres database.
Hmm.
It's kind of like a Web 2 paradigm where data is very cheap. 40 gigs isn't a lot. So yes, you could prune information, but also why not just keep it? Why not? Because
Yeah.
you're only saving what you're interested in.
Right.
It's not really as much of an issue as saving it in a blockchain is because you have to kind of keep that state. Um,
Mhm.
and it is designed to be that situation where you would read this this old data from a subquery data set rather than try to read this old data from a really slow, heavy archive node.
Yeah.
These would be a lot faster and more efficient.
Yeah. No, that makes a lot of sense. But yeah, so you were showing us here this I
Yeah,
guess.
I'll just quickly show a really complex project. So this is what we use to build the UIs for our own application. And this is like next level in terms of, so if I look at my project manifest, for example, what am I doing? Sorry, I'm all over the place. The schema file for this, the GraphQL schema, we're defining like 30 different entities. So for example, an indexer has an entity. The delegator has an entity. The delegations that each of those delegators do have entities. There's like 40 or 50 different entities, and all these in the manifest file, all these different mapping functions. So for example here, now this is an example of a mapping function for an event, an EVM event. This is a Frontier EVM event. The Frontier EVM is what's used by Moonbeam and Astar and a few other networks. And the way you filter EVM events is using topics. But you can see here I define multiple and all these different handlers for all these different topics. So kind of similar to what we've done with all these different handlers, but the way you define these filters is slightly different because it's EVM. But a complex project will have lots of these, which kind of shows off the complexity of a large subquery project that some of our customers build. Great that we're dog fooding our own projects. We have to use it ourselves in our
Yeah, I see what you mean. To just if I understood correctly, that what you're showing is this sort of portal to the subquery network of soon to become incentivized data providers, really, of these data sets.
Yeah.
And you've already got sort of customers that are requesting.
And like we look at even more like other complex things. For example, like Nova Wallet, they index information across all these different networks out there. And for example, this is their GitHub project, and they index, they have a manifest for every chain, as you've seen before. So Astar here, and they index all these different events. They index parachain staking rewards, balances transfers, assets transfers, currencies transfers, and tokens transfers, because there's all these different palettes that relate to transfers, and they have all these different mapping functions inside of them. So this is just an example of like taking it to the next level in a production application, a real world use case. And if you open up the Nova wallet and even sub wallet, use this data set, the data set that you're loading from your wallet comes from the subquery project, which is running in a managed service.
Yeah, that's really cool. Really cool to see, this large scale real world application of the small demo that we just went over.
What I quite like is the subquery network that we're building is designed to run thousands of subquery projects in a decentralized way, but it itself is reliant on a subquery project that we just showed off. And that project will be one of the first itself to be running on the subquery network. So we're kind of like having this weird inception thing going on here where we're trying to decentralize the tech stack for the subquery network itself. So all kind of fun. The dog fooding in the ultimate way. And it's a perfect example at a bit of a huge, scalable, decentralized, and open DApp and protocol. Some final things on my last note, talk about some other features I didn't cover. So we support every Substrate chain that I mentioned. Very simple to change the ones, and you can kind of see how Nova, for example, over here, have it for Astar. They just connect to Astar. That's the only difference. But we also support the smart contract environment languages. So EVM, both Frontier, which is used by Moonbeam and Astar, and Akala's own EVM+. We also support WASM, which is used by Astar and Gear. And then on Cosmos, we support Estimates for these smart contract execution languages. We saw today you can write once and run anywhere. It's got fast performance. It's got a really cool power of GraphQL. And some of the better things of GraphQL is you've seen the filtering, you've seen the aggregation, you've seen the nested queries. You haven't seen subscriptions. So you can make a GraphQL subscription and your front-end app can be notified when a new entity is created. So for example, if you want your front-end app to be really responsive and whenever a transaction occurs, it needs to update instantaneously, you can subscribe from your front-end using GraphQL for all transfers or any new transfer entities match your filter criteria, which is pretty cool. Faster indexing. We actually also, I don't really show this off, but in a way, when you save stuff to the data set, we save the block range that it was valid for. So you can update and mutate data in the data set, and we save the changes of state for that mutation. So an example would be, let's say I'm in my account, I'm saving a current balance. We would automatically keep track of that balance, those changes to that account entity at all times. So you could say, give me the state of this entity at this particular point in time, which is really cool to be able to show the history of stuff, but also it makes indexing and re-indexing really fast because you can kind of rewind to a point. So let's say runtime change happened, you can rewind to that point, update your mapping functions, and then redeploy and carry on, rather than have to re-index from the start. And then finally, it's very lightweight and portable. So you see there's just 3 files I edit. It was a very quick demo. And the main thing is it doesn't require an archive. You don't need it connects directly to an RPC endpoint, and the RPC endpoints, you can find them everywhere, directly to the node from the blockchain. It doesn't require a pre-computed archive of storage. So some other indexes out there, they will use an archive, and that archive is a point of failure. It also adds a delay. So if you want to index real-time data, you have to wait for the archive to get it, and then you have to index information, and then it's available to your application. For us, we're indexing directly from the node. So it's more, and that's really it. Thanks, Sasha. Any questions for you to roll into that?
James, that was awesome. I learned a lot, definitely, and it kind of makes me want to test it out with a small like React app. Just hey, create an application that keeps track of, I don't know, this account's balance transfers and does that in like a dynamic way. I really want to try to use GraphQL in that sense, but like in my app. I guess like you, I mean we're definitely sort of over time and winding down and stuff, but one of the interesting things we didn't get a chance to talk about was dictionaries and how that's implemented. Do you want to say a few words of that on that, or maybe it's for another
Yeah,
seminar?
very simply. So all a dictionary does is store the metadata of when things happen. So a dictionary is a project, itself is a subquery project, but you add it into the kind of the manifest where we right here, you kind of see we have a dictionary defined. It just stores, so it scans the blockchain, and every time it sees any event or a call, it will save the name, it will save it literally just saves it saves the module and the method name of that event and the block it happened in. And so when this project indexes, it goes and asks the dictionary, it says, gives me the next 1,000 block numbers where there is a event from the balances module with the transfer method, and the dictionary looks in the list, gets the next 1,000 blocks for you, returns an array of numbers, and then when this project indexes, it doesn't have to peek into each block to see if this event happens in this block. It just knows automatically looked at this block, at this block, at this block, and this block.
Okay, but so does that just imply that you've on the back end or on the behind the scenes basically these dictionaries are being like pre-computed, and then but I guess I'm not I'm not exactly sure in like how it works, because in this manifest file we're actually asking for a very specific thing, but this dictionary is already pre-generated.
Yeah, that's correct. It's
And with
pre-generated.
everything, it has a whole bunch of different
Just
events and
metadata.
mappings.
Just the block locations of metadata. It doesn't contain the data itself. It doesn't contain the payloads of that data. It just includes the metadata of when those events occurred. So,
Okay, got it.
so it's optional in a way. You don't actually have to use it. It just speeds things up, but it doesn't really. It's not like you can't say that it is a pre-computed store of the information. You're not indexing from the dictionary. You're just using the dictionary to identify where the data that you're looking for is in a faster way.
Cool. Well, yeah, definitely interesting part of this. Well, I guess Jim says we're winding down. Uh, thanks for all this information. You kind of touched on what you're excited for in the new year, what you're going to be working on, but maybe we can kind of wrap up with you giving some insight to potential new contributors to Subquery or new builders that are looking to like build cool things, maybe you can leave us on a note where you kind of are inspiring different types of builders in the space to check out and test and try to break all the things that you guys are building.
Yeah, I think one thing that's clear, and there's still like there's a lot of different grant programs and tasks and challenges out there in Polkadot. There's a lot of stuff that we in the industry know needs to be built. We just don't have the time to build it ourselves. A lot of applications, a lot of those are applications, and I think if you are a developer out there that's looking to get into Polkadot or any other blockchain network, there's a few places to look for. Like look at the different grant programs out there for different parachains. There's even a website, you might be remember what this is called, Sasha, where there's actually like some bounties to do on Polkadot. And that's a great way to get started into this industry. And I hope that in that process, you'll see today, if you want to build an application to solve one of those bounties, Subquery will definitely save you some time and make it easy to build that app that we kind of defined a long time ago. So yeah, I hope Subquery could be a part of that tech stack, just like just like you saw today.
Yeah. Yeah, definitely. I mean, I love how, Subquery is really kind of blockchain agnostic, and you can see that in your docs, right? You have a whole bunch of docs for the different blockchains out there, and I'm not saying different parachains, right? We were just looking at how Subquery can be used in any Substrate built chain, but in that sense, your comment on how could people kind of start building with Subquery and stuff, that it's really just a natural step based on what they're building anyways. They would probably really benefit from a service like Subquery.
Exactly right. We talked to a lot of teams across different ecosystems, and we kind of get a lot of, like, too often we get the response, oh, I wish I knew about you guys a week ago. It would have saved me a week's worth of work trying to build my own indexer. Because everyone you have to build an indexer. You're putting it up front end, you kind of do have to do some indexing. It's inevitable. And so the biggest complaint here is like, damn, I should have heard about you like a wee while ago to save me some time.
That's funny you say that, and it makes me happy because we're doing this, right? We're trying to put out new knowledge out there with Seminar, and especially kind of trying to fill the gaps of knowledge that hasn't really been expressed. And one of the things I like about Seminar is that I really, really try to emphasize that, like, these are important building tools, right? It's not so much about, shilling a specific project. It's really more about sharing different libraries and demonstrating how to use them from a purely developer perspective. And I think we achieved that today with the stuff that you showed us. So I'm really stoked about putting this new information out there. As a tangent to that,
start the mini series on the seminars, Sasha, about how to build a really smart, fast app on Polkadot.
That would be awesome. Yeah, that would be so awesome. We are definitely open to kind of extending the format of Seminar also. So whoever's kind of watching this after the fact, feel free to ping me about new ideas and stuff. And like little mini series would be really cool. What I wanted to mention is that a huge gap of knowledge right now in our documentation is just infrastructure and tooling around infrastructure. So people that are running nodes, people that are running applications that require this type of infrastructure, there's very little knowledge about that stuff. And I recently had a chat with a colleague, a Parody, who's created this really great documentation for DevOps stuff, more specific like to DevOps running infrastructure and troubleshooting. So I really look forward to in the new year, like bridging that gap a little more, right?
That was quite good. I even made a contribution to it, I think.
Cool. Yeah, that's awesome.
So I was like, this is really neat. Who was it?
You have probably spoke with David. No, maybe I don't know.
What's the website called?
I'll share a link. I'm not sure off the top of my head, but it's one of those things where we are moving at such a fast pace. Like even inside of Parity, there's some great projects happening. There's some great knowledge being created, but they tend to be a little siloed, and they tend to take a little more time than people would hope to kind of get out there and stuff. So. But yeah, this piece of doc is actually really great. Oh, I can find it for you. I can't, at least not easily, but I'll share it with you after this call, James. But it's just an example, now going into the new year, I really want to be pushing out new knowledge, bringing new builders in, and providing them with what they need to be successful.
Awesome. Thanks, Sasha. Enjoy
All
the
right.
year, and hopefully it's a really fruitful 2023 for you.
Thank you so much, James. I hope we cross paths soon, and you have a great one out there. A great rest of your day. You killed it. Thank you.